Alright, well, happy snow day to everyone. As I am recording this morning, I do not have my stylus, so please bear with me as far as the handwriting is concerned. I'm just doing this with my finger, so we'll see how this goes. But for the first page, we are just using exponent rules, so you could reference sections 8.1, 8.2, and 8.3 if you need help. But in number 1, we are just going to multiply those exponents, so we get y to the 12th. In number 2, we have to raise everything to the 4th power first, so we have 2 to the 4th, a to the 12th, b to the 4th, and then we still have ab. Now I took out the parentheses because we don't really need them after I distributed that 4. 2 to the 4th power is 16. And then the a and the b actually have an implied 1 on them, so we're going to add these exponents 12 and 1 to get a to the 13th, and the 4 and the 1 to get b to the 5th. Again, I apologize for the handwriting here. Number 3, we are going to add those exponents because there are 2 separate bases. Number 4, we have some positive and some negative exponents, so what I'm going to do is draw a fraction bar, and I'm going to say what flips and what stays. Well, there's an implied 1 on that 7 there, so since it has a positive exponent, it's going to stay where it is. It's going to stay on top. The x cubed has a positive exponent, so that stays. The y to the 4th has a negative, so that flips, and the z to the negative 2 flips as well because of the negative. Number 5, we're distributing in, so we have 5 cubed, p cubed, and q cubed. 5 cubed is 125. And number 6, we flip that because of the negative exponent, and 4 cubed is 64. Number 7 is similar to number 4, only everything starts on the bottom. We still see what flips and what stays. The 1 stays, the 3 stays, the x flips, and the y flips. Notice that the 3 and the 1 have implied 1s on them, so they stay. They're not connected to any of the exponents there. If you did not have the 1 in front of the x squared, y to the 4th, that is okay. Number 8 is negative 12 because all of this is raised to the power of 1, or 0, which is 1, so it's just negative 12 times 1. Here we're going to subtract the exponents. 7 minus 8 is negative 1, which would mean it would flip to the bottom. Number 10. First we are going to combine like terms on top. We get y squared over y to the negative 8th. I'm going to flip that negative 8 up to the top because of the negative exponents, and we get y squared, y to the 8th, and if you add those, you get y to the 10th. Number 11. Alright, there are multiple ways to do this problem, but this is the way that I find the easiest, so you're going to have to follow my words probably a little bit more than my writing because I don't want it to get too sloppy, but like I said, I'm using the top of my finger, so we've got 6x squared, y to the negative 3, over x to the negative 3, y to the 4th. And then here we're going to distribute that negative 2. So negative 2. And then what I would like to do, excuse me, is combine like terms straight across. So I'm going to multiply my fractions straight across. When I do that, my exponents add. So implied on the 6 is a 1. So I have 6 to the 1 and 6 to the negative 2, which gives me 6 to the negative 1. X squared and x to the negative 6 gives me x, or I'm sorry, we just have an x squared. The other, no, here this should be an x. No mistake there. Okay, so we have x squared and x to the negative 6, which would give us x to the negative 4th. We have y to the negative 3, y to the negative 2, which gives us y to the negative 5. Over. There's an implied 1 on this x, So we have x to the negative 3, x to the 1, which gives us x to the negative 2, y to the 4, y to the negative 1, which gives us y to the 3. Alright. So now, I like to flip any of my negatives. So I'm going to put my fraction bar and say what flips and what stays. The 6 flips, the x to the 4th flips, the y to the 5th flips, the x, I think that's to the negative 2, is that right? Yes, to the negative 2 flips, and the y to the 3 stays because that does have a positive exponent on it. Okay, so last step here. We have x's on top and bottom, so we're going to subtract. 2 minus 4 is negative 2, which means it flips. The 6 stays, and then we combine like terms here with the y. So y to the 5th times y to the 3 is y to the 8th. Since there's nothing left on top, we just put a 1. Alright, number 12 is a little bit like number 11, in that we have lots of variables, but it's only half the size. So let's reduce the 15 and the negative 3, just like any other fraction, and we get negative 5, or negative 5 over 1. The y's, we have 3 over 2, so 3 minus 2 is 1. And then what I'm going to do is I'm going to flip that z down to the bottom, and add z cubed, z to the 1. Add those exponents, and we have negative 5y over z to the 4th. Number 13, raise everything to the second power. We get z to the 12th over 3 squared, which is 9. Okay, let's talk about scientific notation. This is section 8.4. Write in standard form because the exponent is positive. We're going to move the decimal place 6 places, which means we will end up with 5 zeros because we already had the 2 there. Number 15, the exponent's negative, so we're going to go to the left, which means we're going to end up with 3 zeros because we have the 6. Number 16, we're changing that into scientific notation, so we should have 5.76 because we want one number to the left of the decimal that is between 0 and 1, and that required us to move our decimal point 1, 2, 3, 4, 5, 6 times. And it has to be to the negative 6 because if we wanted to take this back out of scientific notation, we would have to go left to get the small decimal like that. Here we'd have 2.65 times 10 to the, let's see, what do we got to move our decimal place? 1, 2, 3, 4, 5. We're going to have a positive 5 because if I wanted to change that scientific notation back into 265,000, I'd have to move my decimal place to the right. Alright. Evaluate when x is negative 2 and y is negative 1. So what I would do is I would distribute in this exponent first, and I get x to the 4th, y to the 6th, and then I would plug in. So I'm going to put in negative 2 for x, and then negative 1 for y. Now notice I'm plugging in parentheses because we're squaring or cubing or raising it to the 4th or 6th power for the entire value of the variable. Negative 2 to the 4th power is negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. Negative 1 to the 6th power is negative 1 times itself 6 times, which ends up with a positive 1. So our final answer is 16. Number 19, we're going to plug in 3 for A and negative 4 for B. So negative 3 times 27 times 16, because negative 4 squared is negative 4 times negative 4. You get positive 16. I believe off the top of my head this ends up 1,296, something like that. Okay, graph the function below, show 5 points on your graph. Alright, so if we plug in the points 0, 1, 2, and 3, 3 to the power of 0 is just 1. 3 to the power of 1 is 3. 3 squared is 9, and 3 cubed is 27. And if we go in the other direction, if we plug in a negative 1, what that does is it makes us get 1/3, because it would flip this exponential. And you will see that we get very close to 0, but we never actually cross 0 because there's nothing that would make that negative. This is growth because from left to right we are going up. This one is going to be, if we do 0, 1, and 2, anything to the power of 0 is 1, anything to the power of 1 is itself, so 1/3. Square it, you get 1/3 times 1/3, which is 1/9. So what happens is it flips basically all of the values from above. When you have a negative 1, that's when you get 3. When you have negative 2, that's when you get 3 squared is 9, because you have to flip this. So I'm going to say negative 2, 9, negative 1, 3, 0, 1. It's going to come down like this. This is decay, because from left to right it is going down. These problems, there's more examples in your 8586 video. So if you do the 8586 graphing video, it's done a little bit nicer there with my stylus. Okay, are the following functions growth or decay? You are looking at the number that has the exponent on it. So what number is being raised to the exponent? What is the base? If it's smaller than 1, it is decay. If it is bigger than 1, it is growth. Don't worry about the sign. Is it reflected? That's when you're looking if it's positive or negative. There's no sign out front here, so this is not reflected. This is reflected because of the negative. Not reflected is reflected because of the negative. Not reflected. Okay, how is it shifted? Now, if there's a number up here in the exponent with the x, that shifts left and right, but it's opposite of what it looks like. If it's a big number off at the end, that's what shifts up and down, and it is whatever it looks like. So if it's positive, it goes up, but if it's negative, it goes down. So this one does not shift left and right because there's nothing with the x, but it does shift down 3. This one has a number with the x, and it says -3, but actually h lies, so we're going to go right 3. This one says +2, but we're actually going to go left 2, and then it has -2 off at the end. K tells the truth, so we are going to go down. So this is going to have 2 shifts, left 2, down 2. This one goes the opposite of -5, so right 5, up 4. This one does not shift left and right. It does shift up 2, however. Alright, compare the graphs from A to B. Here we have a y-intercept of 1. Here we could see that that y-intercept has shifted left 3. This one, we have a y-intercept of +1. Here we could see that it shifted up to 3, so we shifted up 2 units. Here we have a y-intercept of -1. It is a linear function. We are shifting up to 4, so that means we have shifted up 5 units. I think the table's kind of messing up my writing here. It's shifted me all around. And this one has a y-intercept of +1. This has -1, but if you notice this was not reflected and this is, that's the only shift here.